This presentation is provided by Dr. Bastian Schroeder and Chris Cunningham from the Institute for Transportation Research and Education at NC State University. We are going to share some information about an automated yield detection system developed in recent years to assist visually impaired pedestrians with crossings at roundabouts or channelized turn lanes. Research in this area is still ongoing, so please continue to monitor our website for updates to this system.
My name is Dr. Bastian Schroeder. I'm a research associate at ITRE, the Institute for Transportation Research and Education, affiliated with North Carolina State University. We're here at the Poland Road and Catherine Stinson Drive roundabout, just east of the campus of North Carolina State University. And we're conducting a study to help pedestrians who are blind cross at these roundabouts and other complex intersections using a technology called the Advanced Yield Detection System. Generally, the way that this technology would work is that when they're activated, it will play a locator tone to actually help the pedestrian also locate the crosswalk. And so they can help find the crosswalk and use tactile information on these and little arrows to figure out where the crossing is and align themselves to the crossing. And then as they push the button, a signal will be sent to our controller that tells the system that a pedestrian is indeed waiting to cross. And so after that has happened, and then a vehicle stops for the pedestrian, there's a loudspeaker built into these, and the speech message will then come on and tell the pedestrian that it's okay to cross, or that a vehicle has stopped.
Entering vehicle has stopped.
We always make sure that the pedestrians still know that they need to rely on their own judgment as much as anything else. So this technology is intended to assist the pedestrian in making crossing decisions, not making all the decisions for them. So we place a heavy emphasis on making it clear to our volunteers that you still need to, use your own judgment when you cross.
Shown is a split-screen view of the automated yield detection system in use by one of the visually impaired subjects assisting us with our experiment. There are 4 fields of view. On the top left, a ground-mounted camera is used to verify the scene. The top right video provides a view of the detection card that ties into the signal controller. This is used by the research team during post-processing of the data. The bottom left and right videos show the video detection algorithm in use at the exit and entry crossings respectively. The video clip preceding shows the visually impaired pedestrian crossing the exit first, followed by an entry crossing. You may need to adjust your speakers to hear the orientation and mobility specialist who is running the experiment. Although the orientation and mobility specialist runs the experiment, his role is to make sure the pedestrian does not make an unsafe movement by crossing in front of a moving vehicle.
This is exit lane crossing, vehicles from your left, vehicles approaching from your left. Approaching the crossing point. At the crossing point, drop my arm, wait. Cross when you are ready.
It's coming from the left, correct?
Left, correct. Good. Stop. Nice job.
This technology is entirely portable. These pedestrian push buttons have been designed in a way to where they can be picked up and moved and carried to different locations. And all of our technology is mounted on top of an equipment trailer. The telescoping pole that you see is completely collapsible and fits into an equipment trailer that we can move to other locations.
It's basically a data collection lab that we can use for all kinds of purposes, but in this application we actually use it to detect when yielding vehicles are taking place. We had a couple of cameras in overhead positions. One in this case is mounted overhead on a mast, and then the other one's mounted on top of a building. We can put those in any application. Basically what happens is the cameras look for pixel changes through a system of loops. And as pixels change, it can detect whether a vehicle has yielded or not. We're able to view this on a monitor, and then the signal controller actually takes the information from the cameras, and that's actually done, most of the functioning is done through the cameras, but the signal controller takes when vehicles are yielded and then looks for an activation of the APS device to take place, and then says whether or not the vehicle has yielded. So the controller kind of takes the information from the video and from the push button APS devices, and then determines whether or not a message needs to be sent. We also have the ability to record data to post-process all kinds of information.
The genesis of the project really started from a National Institute of Health grant given to Western Michigan University that include a partnership between folks who do vision research and engineering research. NC State was not initially in the original team that submitted for the grant, but very quickly Western Michigan realized that the capability here at ITRE were very important from a couple of perspectives. The ability to do some prediction of what the technology to assist blind pedestrian crossing is going to do, both in the field, also in some numerical computer simulation. So one of our biggest contribution to the research has been the development of this automated yield detection system. We have tested that system on a couple of pilot studies, one as recently as this past spring, and at least the initial indication, both from the perspective of the blind individuals who were interviewed at the conclusion of the study, as well as evidence, the actual data that indicated that the percentage of yields that were taken went up from something like 45 to 70%. So we feel, even though the system is not certainly of any commercial grade, that it has done its job, that it appears to be functioning. Of course, there is room for improvement, but certainly this would be a much better approach than going all the way to putting traffic signal on all the roundabouts, which would basically defeat the purpose of their operation.
We sincerely appreciate you taking the time to view this presentation. If you have any questions about the yield detection system, we'd be happy to entertain those. If this topic interests you, please remember to look for future videos and publications, as research is still ongoing. We are currently testing a similar system which also looks for crossable gaps. Finally, please take time to view our website at itre.ncsu.edu for papers and publications on the topic of pedestrian accessibility.